Okay, section 2.2, we're dealing with linear programming. In the last section, we talked about inequalities, graphing inequalities, feasible regions, objective functions. Now we're going to do that same thing, but everything is embedded, embedded or encrypted or worded or whatever in a word problem. So we're going to see problems that look a lot like this, okay? And what we need is just a strategy for breaking it down. Every problem that I read like this, the first thing it does, it makes my head spin. There's too much stuff. You got to learn how to attack it. So Perfect Parking Company has 600 square meters of parking available to customers. The hourly rates are $2.50 for cars, $7.50 for buses. The average car requires 6 square meters. The bus takes 30 square meters. If the lot is only allowed to handle 60 vehicles, how much of each vehicle type should be accepted to maximize the income? What is the maximum income? So here's our process. We need variables, okay? We need constraints. We need an objective function. After the objective function, what is the goal of the optimization? Are we maximizing or minimizing? You can tell in this one we're maximizing income. Once we get all this stuff together, we will graph. We will come up with a feasible region. And that's a shaded area. It will have vertices. We will take each of those vertices, we will plug them in the objective function, and then we'll answer our original word problem. So those are the steps. It sounds like a lot. You don't have to memorize the steps. These problems, if you work enough of them, it will sort of come into focus. Okay, the first thing I need to define the variables. The best way to define the variables is look at your original problem, and somewhere embedded in the questions is a big old clue as to how to define the variables. If the lot is allowed to handle 60 vehicles, how many of each vehicle type should be accepted? Those are my variables. The number of the vehicle types. Okay, so in this problem, I have what? Buses and cars for my variables. So what I'm going to do, since I have buses and cars, that's going to be my variables. So I've broken down this problem into several things. How many of each vehicle type should be accepted to maximize the income? So buses and cars. So B is equal to the number of buses. And C is equal to the number of cars. Now you could write C as the number of cars, B as the number of buses. You can pick different letters. Don't care what you do, but I want you to be very consistent. If you write B first and C second, I want you to go ahead and go to your graph and write B and C, okay? So you will not get confused. If B is the first variable you write, then I want B to be first and C to be second. The next thing I'm asked to do is to define my objective function. So what is it they're after in this problem? They are after me finding the maximum income or revenue, okay? So what's being optimized here? It's the revenue or income. I am being asked to maximize that, okay? So where do I get the function that tells me that? If I look at this problem, it tells me that there are hourly rates, $2.50 for every car and $7.50 for every bus. So my objective function, I'm trying to maximize the revenue. Now because I listed B, I listed my variables B and C, I want my objective function to be in terms of B and C and in that order. So B, how much money do I get for a bus? It looks like I get $7.5, okay? How much money do I get for a car? It looks like that is 2.5 for every car. So note what I did here. My variables were B and C. I listed them in that order. My objective function is in terms of B and C. It is in that order, okay? And then my graph is going to have B and C for the horizontal and vertical axis, okay? All of that consistency will help you because when you want to go plug in your numbers, if the C and the B are mixed around in this objective function, you're likely to mix up what gets plugged in where. So it's just for your consistency, putting everything in the same order will help. So now let's just copy down what we've done so far. We've got the objective function revenue is equal to 7.5b plus 2.5 times C. Our variables, we have B, that represents the number of buses, and C represents the number of cars. Now I'm ready to figure out what my constraints are. And now I just look at the problem. It looks like the constraints are I have a certain amount of space for parking, and it looks like the other constraint is I can only hold a certain number of vehicles. So if I look at the space, okay, so I have 600 square meters of parking, okay, so that's my limit. I can never park more than 600 square meters, okay, and how much does a bus take up? So the average car is 6 square meters, and the bus is 30 square meters. So every bus will take up 30 square meters. So that's the amount of space taken up by the buses. And then the car is going to take 6. So that's the amount of space that the cars take. And that can be no more than 600 because that's the limit of my parking lot. Okay. Now the other constraint, I can only be allowed to handle 60 vehicles. So what that means is I can handle up to 60. I can't go over 60. So the number of buses plus the number of cars has to be less than or equal to 60. Now I use this chart that represents everything you see in this problem. That helps me define what my constraints are that I need to graph. Now every one of these problems is going to have the constraint that you don't want to miss. B is equal or greater than equal to 0 and C is greater than equal to 0. I can't have a negative number of buses or a negative number of cars. It has to be positive. Now what I will do, I will just write down the two constraints. I've got 30B plus 6C is less than or equal to 600. And I'm going to use a different color. It's really helpful in these. B plus C is less than or equal to 60. And now let's just go graph. So these are all my constraints. In this first problem, let's pick values of B and C. If B is equal to 0, then C is equal to, if B is equal to 0, then C is equal to no, 100, sorry. So B is equal to 0, C is equal to 100. If C is equal to 0, then I get B is equal to, is that 20? So I get those points. And then let's look at B and C. This one's pretty easy. If B is equal to 0, C is 60. And if C is 0, B is 60. Now I just need to graph the lines associated with those two constraints. So it looks like my axis for B needs to scale from 0 to 60, and my axis for C from 0 to 100. So from 0 to 60, I can do on the B axis, this is what, 20, 40, and 60. I want to try to use as much of this graph as I can. And then for my C axis, I need to go up to 100. So I can do 25, 50, 75, 100. What I want to avoid is my graph being somewhere down in here, just the little spaces. So I want to make sure I use as much of this graph as I can by scaling my axis. So let's graph. 0, 100 is this point, and 20, 0 is right here. I need to draw the line associated with these 2 points. Okay, and this condition right here is telling me to shade below that line. Okay, now let's look at the blue one. I'm going to have 0, 60, so that is right here, and 60, 0, which is right here. And let's connect the line with those two. And again, this constraint that you see right here is telling me to shade below this line. So if I shade below the blue and below the green, it looks like my feasible region is right here. And that I just need to figure out what the vertices are. So right there, and right there. Okay. So if I look at it, one of the reasons I like the color is I can tell the vertices, like this point right here that's one of my vertices, and this is one of my vertices. And the other vertex is where the green line and the blue line meet. If I look at this, it looks like this is a 50 right here, so maybe it's 1050. I don't know, but I know this one is 060. That's this point. This point is 20, 0. Okay. If I did my graph, I think this is 1050. I'm not sure. I want to verify that, and I'll verify that in just a moment. Okay. So we'll verify that by just looking at those two lines. So it was what, 30? And we'll use our calculator to do that. So let's verify where the green and the blue line intersect. So on my calculator, that's just menu, algebra solve system, 2x2 system. My variables happen to be what, B and C. So B, comma, C. And I'll say, okay, those two equations were 30B plus 6C. So 30B plus 6C equal 600. And then the next equation was B plus C equals 60. So B plus C equal 60. And let's go back and correct that. That should be good. It tells me 1050 is the intersection. So B is 10, C is 50. Okay, so my graph was correct, and I've got the 3 points. Now I just need to evaluate each of these points. So I'm going to evaluate the objective function. Again, the objective function was what? My revenue was 7.5 for every bus plus 2.5 for every car. So let's evaluate that at each of these functions. So I'm going to evaluate my revenue at the point 20, 0. Evaluate the revenue at the point 0 and 60. And I've got revenue at the point 1050. So this is 7.5 times 20 plus 2.5 times 0. This is 150. And then I've got 7.5 times 0 plus 2.5 times 60. That's also 150. And then I've got 7.5 times 10 plus 2.5 times 50. And that is 200. So what was the goal of my original problem? The goal of my original problem was to maximize the income, okay? So I now know that that maximum income is $200. So I will maximize, so my maximum income is $200, and I get that when I have 10 buses and 50 cars. Okay, these problems are long. They're involved. They have lots of steps, but you need to be able to just break them down into components. So each thing has multiple steps. You got to be able to concentrate and organize. You see me using straight edges, or using straight edge on your paper, different colors. Be consistent with the variables. When I define my variables, like I just did B and C, if B was first, that's my x-axis, C is my y. And every time I wrote an equation with B and C, B was first and C was second. Be consistent to save yourself from making mistakes. The original problem has words in it. Your answer has words. And make sure you answer. Go back before you're done and answer the original question. So in this problem, it said if the lot is allowed to handle 60, how many of each vehicle type? So your answer should say something like, 10 buses and 50 cars in the parking lot for a maximum income of $200. So make sure what we did a moment ago, our answer basically said that. So you want to make sure that your answer precisely answers the question. Okay, let's do a couple more. Again, you might want to work these, even if I've worked it or worked it in class, it might be worth your while to work the problem again, okay? Just so that you make sure you are comfortable with everything. So War Eagle Bakery makes decorated sheet cakes for parties, a full sheet and a half sheet. The full sheet cakes takes 4 hours in the oven and 2 hours decorating. The half sheet takes 2 hours in the oven and 4 hours decorating. The oven and the decorating rooms are each available 24 hours a day. The bakery makes a profit of $30 on the full sheet and $35 on the half sheet. How many batches of each type should they make? What is their profit? My first thing that I would do before I go to sleep reading all of that kind of stuff is look at my questions. One of those questions will tell you the variables. How many batches of each type should they bake? So that tells me my variables are the batches. What am I baking here? I'm baking cakes. I'm baking a full and a half. So I'm just going to say F equal the number of full. H equal the number of half. The minute I do that, I wrote F and H. I'm going to write F and H. So every time I write this from now on, F is my first variable, H is my second variable, okay? You could flip those around. You could write H and F. The minute you do that, make sure you are consistent every time, okay? The objective function, what am I trying to maximize or minimize here? I'm trying to maximize my profit. So I'm trying to maximize the profit. So there's going to be a profit function, P is equal to, because I wrote F and H, it's going to be something F plus something H, okay? So what is the profit on a full? It looks like the profit is $30 on a full and $35 on a half, okay? So that's my profit function. Now I just come down and I got to figure out everything else I need to extract from this problem is going to have to deal with the constraints. It looks like the constraints I see here are, it takes oven time and it takes some decorating time. And let's just break it down. So if I look at the oven, how much time does a full stay in the oven? The full stays in the oven for 4 hours. So that's the amount of time that the full cakes are in the oven. The half cake takes, what, 2 hours of oven. And how much oven time do I have to work with in this bakery? It says the ovens are available 24 hours a day. So that means I cannot use that oven for more than 24 hours. So some number less than 24. Decorating. It says that the full takes 2 hours to decorate and the half takes 4 hours to decorate. It must be fancier. And again, my decorating room is only available 24 hours a day. So these are going to help me build my constraints. So let's go now to graphing. Constraints. Do not lose points because you forgot to write F is greater than or equal to 0, H is greater than or equal to 0. And now I've got the two strengths that I will graph. I'm going to have 4F plus 2H is less than or equal to 24. And the next one I'm going to have is 2F plus 4H less than or equal to 24. And if I look at this, I have F and H. When F is 0, H is 12. When H is 0, F is 6. And the next one here, F and H. When F is 0, H is 6. When H is 0, F is 12. So now I just need to graph these two constraints. So starting out with the red one. So I need to go up to 0, 12 on both axes. So it looks like I can go something like, I could go 2, 4, 6, 8, 10, 12, and 2, 4, 6, 8, 10, 12. So 0, 12 is right here, 6, 0 is right here. Connect those two dots. And let me try to connect that. Okay, and I'm going to be shading below that line. Okay, so this tells me shade below that line. And let's look at the blue one, 0, 6 and 12, 0. Right here, if I connect those two dots, it looks like, and I also need to shade below that line. So shading below both of those lines gives me a feasible region that looks like this. Okay, and so I've got the points. My vertices are 0, 6. I get that point from right here. So 0, 6. The other point I see is right here. That point is 6, 0. And then where do these two lines intersect? That looks like 4, 4. Okay. I did my graph pretty good, so I think that's a max. But again, I don't want to trust that. Okay. I want to verify that. So again, to verify that, I'm going to have 4 and 2. So let's just go ahead and solve this real quick. So menu, algebra, solve, two equations, two variables. My variables were f and h, is that right? So variables were f and h. So f, comma, h. And so I'm going to have 4f, is that right? The first one was 4f2h. So 4f plus 2h. I'm graphing the line where it equals 24, okay? And then the next line was 2f plus 4h. 2f plus 4h equal 24. Solve that, and the answer is 4, 4. So f is 4, h is 4. So back to this. So now I just need to plug in that profit function. So that profit function was what? 30f plus 35h. So profit equal 30f plus 35h. So evaluate. What is my profit at 0, 6? What is my profit at 6, 0? And what is my profit at 4, 4? So this is 30 times 0 plus 35 times 6. And that gives me 210. The next one is 30 times 6 plus 35 times 0. That is 180. And then lastly, I get 30 times 4 plus 35 times 4. That is 120 plus 140, which is 260. So where is my profit? My maximum profit occurs right here. So you've done all the work. Answer the question. The original question. How many batches of each type should they bake, and what is the profit? Okay. So it looks like I should make 4 of each. So this tells me make 4 full cakes, 4 half cakes, and my max profit is $260. Okay. So again, these problems can get long, but we do have a process for going through these methodically to get to the answers. Okay. Let's take a look at the last problem in this section. The elite tweet pottery shop makes two kind of bird baths, fancy glazed and simple unglazed. The unglazed requires 1/2 hour on the pottery wheel, 1 hour on the kiln. The glaze is 1 hour on the wheel and 5 hours in the kiln. The one pottery wheel is available for most 8 hours a day. The 6 kilns are used for at most 24 hours a day. The company has a standing order for 5 unglazed, so it must produce at least that many. The profit on each bird bath unglazed is 10. The profit on the glazed is 40. How many of each bird bath should be produced in order to maximize the profit? What is the maximum profit? Okay, so how do I define my variables on this? Look at your question. So the question was, how many of each bird bath should be produced in order to maximize the profit? What is the maximum profit? So what I'm going to do here, I'm going to let G be the number of glazed bird baths and U be the number of unglazed. Okay. The minute I do that, this is my G axis and this is my U axis up here. Okay. Next, I need an objective function. What is my objective here? I'm trying to do what? Maximize profit. So I have a function for profit. And because I define the variables G and U, it's going to be something G plus something U. What is the profit on each glazed? So the profit on the glazed is 40, and the profit on the unglazed is 10. So that is going to be my objective function. Now we look at the constraints. There were a couple constraints. There was a pottery wheel and there was the kiln. Okay, so let's look at it. You're going to have constraints like this. Okay, so let's look at the pottery wheel. The glazed bird bath takes 1 hour on the wheel. Okay, so 1 hour on the wheel. And then what about the unglazed on the wheel? The unglazed takes 1/2 hour. So I'm going to write, I'll just go ahead and write it 0.5, okay? So it takes 0.5 hours. And what's the limit on the wheel? Okay, so it tells me that the wheel is available for at most 8 hours a day. So 8 is as big as it can get, okay? No more than 8. So there's a limit of the wheel is available for no more than 8. Okay. Now let's look at the kiln. The glazed, so if I look at the glazed bird bath takes 5 hours on the kiln. So glazed takes 5 hours. And then the unglazed takes 1 hour. Okay. And I know that the kiln is what? I've got 6 of them, but they can be used for at most 25 hours a day. So 25 is as most that can be, so less than or equal to 25. And then there's something else. The company has a standing order for 5 unglazed bird baths per day, so it must produce at least that many. So the number of unglazed, it says, has to be at least 5. That means 5 is the smallest number I can have. So it's okay for it to be bigger than that. So the number of unglazed has to be greater than or equal to 5. So I've got to have at least 5 of those per day. These are all my conditions. I'm ready to go and graph now. Okay? So I've got my objective function, my constraints. Never miss this one. G is greater than or equal to 0. U is greater than or equal to 0. Okay? You get points for that. Okay? Now let's look at our conditions. It looks like I have 3 here. So I'm going to have G plus 0.5 U is less than or equal to 8. I'm going to have 5G plus U less than or equal to 25. And I've also got the condition that U is greater than or equal to 5. So let's start with the first one here, G and U. if G is equal to 0, then 0.5 times what number is 8? That's going to be 16. If U is equal to 0, then G is equal to 8. Our next condition, look at G and U. If G is equal to 0, U is equal to 25. If U is equal to 0, G is equal to 5. Now this condition right here, U is greater than or equal to 5, that one's pretty simple. It's just the U values have to be greater than or equal to 5. So let's just start graphing. Let's look at the red line. So I need to graph my G goes from what, 0 to 8, 0 to 5. So the G-axis, if it went from 0 to 10, that would be good. The U-axis needs to go up to 25. So I can't quite do every one, so I can probably do something like this. This could be 10, and this could be 20, and this could be 30 for the U-axis. And on the G-axis, I need to go up from 0 to 8, so that one would be fine. Just go 1, 2, 3, 4, 5, 6, 7, 8. Should be good there. So 0, 16. Okay, so if this is 10, so each of those is 2. So 0, 16, 2, 4, 6, which is right here, and 8, 0, which is right here, and connect those two dots. Okay, that's pretty good. I will be shading below that line. Okay, now let's look at the blue line, 0, 25. So 0, 25, so 2, 4, somewhere about in the middle right here, and 5, 0. 5, 0 is right here. If I connect those two dots, and I will be shading below that line. So shading below that line. Sorry about this. Okay, so shading below that line. So I'm shading below both of these lines, okay? But I've got another condition. U is greater than or equal to 5. So look at your U axis, which is this vertical axis. 2, 4, 6, 8, 10. So somewhere right in here is 5, right here. So if I can draw a line that goes right through there, U has to be greater than or equal to 5. So my constraint is below the red line, below the blue line, and above the green line. So this is my feasible region, okay? So where are my vertices? Here's one right here, where the blue and the red line intersect, where the blue and the green line intersect, and then also right here. Those are my vertices. So what are they? Where does the red line hit the axis? That's right here. So this is 0, 16. I know that one. And then if I look at this right here, this is the green line. That's it. That point is at 5. So that's 0, 5. So I know I've got 0, 5 there. And then what happens on the blue line when the G value is 5? So on the blue line, excuse me, not 5, when it is right here, when the U value is 5. So in this case, I'm looking for this point that you see right here. That's the point you get when u is equal to 5. When u is equal to 5, g is equal to 4. So that is the point 4, 5. And then what I'm left to find is where do the red and the blue line intersect. I'm thinking maybe it's 310. I'm not sure, but I got to check that. So I'm going to use my calculator to check where those lines intersect. So I'm going to have to look at g plus 1/2 u equal 8 and 5g plus u equal 25. I just want to guarantee where those lines intersect to make sure I'm getting this correct. So menu, algebra, solve system equations, two variables. My variables happen to be g and u. So g, comma, u. And I've got g plus 1/2 u, so g plus 1/2 g plus 1/2 times u equal 8. That's the first equation. And then 5g plus u equal 25. So 5g plus u equal 25. Solve that and I get 310. Okay, so I now know all the vertices. That's 310. And what was my objective function? So my objective function was 40g plus 10u. So I need to figure out what is this objective function at 0, 5. What is this function at 0, 16? What is this function at 310 and 4, 5? So let's evaluate and we should be done. So this is 40 times 0 plus 10 times 5. That's 50. This is 40 times 0 plus 10 times 16. That's 160. This is 40 times 3 plus 10 times 10. That's 120 plus 100. That's 220. This is 40 times 4 plus 10 times 5. That's 160 plus 50 equal 210. So here's my maximum. So I have a maximum profit of 220, and that comes from making 3 glazed bird baths and 10 unglazed bird baths. And that is it. So again, these problems are long, but you want to spend time, get familiar with the process of how they each set up, and make yourself more comfortable with that process.